Hello students, in my previous video I have completed sums of 12.1 and today in this video I am going to show sums of 12.2. Now question number 1 is, a solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 cm and the height of the cone is equal to its radius. Find the volume of the solid in terms of pi. Now as given in the question, a solid is in the shape of a cone standing on a hemisphere. So this is the hemisphere and this is the cone. And radii of both the figures, that is cone and the hemisphere, is given 1 cm. We have to find the volume of this figure in terms of pi. So in conical part, radius is r and height is 1 cm. In case of hemispherical part, radius is 1 cm. Now we need to find the volume of the solid. Now here two figures are involved, one is cone, another is hemisphere. So volume of the solid is volume of the conical part plus volume of the hemispherical part. In case of cone, volume is 1 by 3 pi r square h, and in case of hemisphere, it is 2 by 3 pi r cube. Now from these two terms, I can take 1 by 3 pi r square common. So if I take 1 by 3 pi r square common, then from this term we are left with h, from this term we are left with twice r. Now 1 by 3 pi, radius is given in the question 1 cm. So instead of r I can write 1 square, height is 1, radius is 1, so it will be 2 into 1. So it will be pi by 3 into 2 1 2 plus 1 3. These 3 and 3 can be cancelled, so we are left with pi. So pi centimeter cube is the volume of this figure. Question number 2. Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at its two ends by using a thin aluminum sheet. The diameter of the model is 3 cm and its length is 12 cm. If each cone has a height of 2 cm, find the volume of air contained in the model that Rachel made. We have to assume that the outer and inner dimensions of the model to be nearly the same. Now as given in the question, that she has prepared a model with a cylinder in the middle and two cones in the end. It is given that the diameter of the model is 3 cm and its total length is 12 cm. Now in case of each cone, it is given that height is 2 cm and diameter of cone and diameter of the cylinder are same. Now in case of conical part, height is 2 cm. So we can consider h1 is 2 cm and radius, since diameter is 3, so radius will be 3 by 2. So r is 3 by 2 cm. In case of cylindrical part, height h2 will be, total height is 12. This part is 2, this part is also 2. So the height of the cylinder will be 12 minus 2, which will give 8 cm, and radius of the cylinder is also 3 by 2. Now we have to find the volume of air in this model. So for this, volume of air contained in the model will be twice volume of cone plus volume of cylinder. Now we know volume of cone is 1 by 3 pi r square h. So here volume of air contained in the model will be 2 into volume of each cone plus volume of cylinder. 2 into 1/3 pi r square h1, where h1 is the height of the cone. For cylindrical part, it will be pi r square h2 and h2 is the height of the cylinder. From these two I can take pi r square common because radius in both the cases are same. So pi r square I have taken common. So I am left with 2 by 3 h1 plus h2. So pi, radius we know 3 by 2 whole square. 2 by 3, h1 we know it is 2 plus h2 is 8. So pi into 3 square is 9, 2 square is 4. 2 2 is 4 by 3 plus 8. Here if I take LCM 3 divided by 3 1, 4 1 is 4 plus 3 divided by 1 3, 3 8 is 24. That means pi into 9 by 4 into 24 plus 4 will give 28 by 3. Now 3 and 9 can be cancelled, it will be 3. 4 and 28 can be cancelled, it will be 7. Now pi is 22 by 7 into 3 into 7. 7 and 7 can be cancelled. 3 into 22 is 66. So 66 centimeter cube is the volume of air present in the model. In question number 3 it is given, a gulab jamun contains sugar syrup up to about 30% of its volume. Find approximately how much syrup would be found in 45 gulab jamuns, each shaped like a cylinder with two hemispherical ends with length 5 cm and diameter 2.8 cm. In case of hemispherical part, diameter is 2.8 cm, so radius will be half of it, that is 1.4 cm. So we can write in hemispherical part, radius is 1.4 cm. In case of cylindrical part, radius will be same as hemisphere, so radius is 2.8 by 2, that is 1.4 cm. Now what is the height of the cylinder? It will be 5 minus 1.4 minus 1.4. So 5 minus 1.4 minus 1.4 will give 2.2 cm. So we got in case of cylinder, height is 2.2 cm and radius is 1.4 cm. In case of hemispherical part, radius is 1.4 cm. Now we have to find the volume of each gulab jamun. Here two hemispheres are given and in the middle it is one cylinder. So volume of each gulab jamun will be volume of cylindrical part plus 2 into volume of hemispherical part. We know volume of cylindrical part is pi r square h. In case of hemisphere, it is 2 by 3 pi r cube. Since there are two hemispheres, so we have to multiply by 2. From this 2, I can take pi r square common. So here we are left with h plus, since pi r square taken common, so we are left with 2 to the 4 by 3 r. Pi is 22 by 7 into r square, radius is 1.4, so it will be 1.4 into 1.4. Height of the cylindrical part is 2.2 plus 4 by 3, radius is 1.4. 22 by 7 into 1.4 can be written as 14 by 10 into 14 by 10. 2.2 plus 4 into 1.4 will give 5.6 by 3. 7 and 14 can be cancelled, so it will be 2. So we are left with 22. 2 into 14, 28. 10 into 10, 100. Into, here 3 will be the LCM. 3 into 2.2 will be 6.6 plus 5.6. So it will be 22 into 28 by 100. 5.6 and 6.6 if I add, I will get 12.2 by 3. Now if I multiply 22 into 28 into 12.2, it will give 7515.2. 3 into 100 will give 300. If 7515.2 is divided by 300, it will give 25.06 centimeter cube. So this is the volume of a gulab jamun. Now we have to find the volume of 45 gulab jamuns. So we need to multiply this value by 45. So 45 into 25.06 will give 1127.25 centimeter cube. As given in the question, volume of sugar syrup is 30% of the volume of 45 gulab jamuns. So 30% means 30 by 100 into volume of 45 gulab jamuns. We have already calculated 1127.25. 0 and 0 can be cancelled. If I multiply 3 and 1127.25, it will be 3381.75 divided by 10. If 3381.75 is divided by 10, it will give 338.17 centimeter cube. Therefore, sugar syrup found in 45 gulab jamuns will be 338 centimeter cube, which is the approximate answer. Question number 4. A pen stand made of wood is in the shape of a cuboid with 4 conical depressions to hold pens. The dimensions of the cuboid are 15 cm by 10 cm by 3.5 cm. The radius of each of the depressions is 0.5 cm and the depth is 1.4 cm. Find the volume of the wood in the entire stand. This is the pen stand in which pens are to be kept. These depressions are conical in shape. We have to find the volume of wood in the entire stand. Here, this is the pen stand whose length is 15 cm, breadth is 10 cm and height is 3.5 cm. So we can write in cuboid, which is the pen stand, length is 15 cm, breadth is 10 cm and height is 3.5 cm. These conical depressions I have drawn here. Here, height is 1.4 cm and radius is 0.5. So in case of each conical depression, radius is 0.5 cm and height is 1.4 cm. Now we have to find the volume of the wood in this stand. So volume of wood in the stand will be volume of cuboid minus volume of 4 cones. So we can write here volume of wood in the stand equals to volume of cuboid minus 4 into volume of each conical depression. Now in case of cuboid, volume is length into breadth into height. minus 4 into volume of each conical depression. For each cone, volume is 1 by 3 pi r square h. So 15 into 10 into 3.5 minus 4 into 1 4. So it will be 4 by 3 into pi. Radius is 0.5 in case of cone. So 0.5 square. Height of the conical depression is 1.4. So if I multiply these 3, it will be 525 minus 4 by 3. Instead of pi, we can write 22 by 7 into 0.5 square is 0.25 into 1.4 can be written as 14 by 10. Now 7 2 ja 14. Now 3 into 10 30. Here 4 into 0.25, it will give 1. So 22 into 2 is 44. So in the numerator it will be 44. So it will be 525 minus 44 and 30. If I cancel by 2, it will be 22 by 15. So I have written here 22 by 15. Now here 525 by 1. So if I take the LCM of 1 and 15, it will be 15. 15 divided by 1 is 15. 15 into 525 will give 7875 minus 15 divided by 15 is 1. 1 into 22, 22. If we subtract 22 from 7875, it will give 7853 by 15. If I divide 7853 by 15, it will give 523.53 centimeter cube. Therefore, volume of wood in the stand is 523.53 centimeter cube. Question number 5. A vessel is in the form of an inverted cone. Its height is 8 centimeter and the radius of its top, which is open, is 5 centimeter. It is filled with water up to the brim. When lead shorts, each of which is a sphere of radius 0.5 cm, are dropped into the vessel, 1/4 of the water flows out. Find the number of lead shorts dropped in the vessel. Here, this is the inverted cone whose radius is 5 cm and height is 8 cm. In case of each lead short, it is given radius is 0.5 cm. So we can write in case of each lead short, radius is 0.5 cm. In case of conical vessel, height is 8 cm and radius is 5 cm. We don't know how many lead shorts are dropped, so let it be n. So we can write let number of lead shorts be n. Now according to the question, volume of lead shorts is equal to the volume of water spilled. As it is given 1/4 of the water flows out, so volume of water spilled will be 1/4 of volume of the cone. Now volume of lead short, there are n lead shorts, so n into, and volume of each sphere is 4 by 3 pi r cube equals to 1/4 of volume of cone. As it is given 1/4 of the water flows out, so n into 4 by 3 pi r cube equals to 1/4 into 1/3 pi r square h. This is the volume of a cone. So n equals to 1 by 4 into 1 by 3 pi r square h into these 3 will come in the numerator and 4 pi r cube will be in the denominator. Now pi and pi can be cancelled, 3 and 3 can be cancelled. So n equals to r square. R is 5, so it will be 5 square into height of the cone is 8. So we have written 8 here, divided by 4 into this 4 into r cube. Radius of each lead shot is 0.5, so it will be 0.5 cube. Now 8 and 4 can be cancelled, it will be 2. So n equals to 5 square is 25, 25 to the 50, 4 into 0.5 means 1 by 2, so 1 by 2 cube. So n equals to 50 divided by 4 into half cube will give 1 by 8. Now 4 and 8 can be cancelled, it will be 2. So n equals to 15 to 2, which will give 100. Therefore number of lead shots that is dropped in the conical vessel is 100. In question number 6, it is given a solid iron pole consists of a cylinder of height 220 cm and base diameter 24 cm, which is surmounted by another cylinder of height 60 cm and radius 8 cm. Find the mass of the pole given that 1 centimeter cube of iron has approximately 8 gram mass, and here we have to use pi equals to 3.14. Here it is given there are 2 cylinders. In case of lower cylinder, diameter is 24 cm and height is 220 cm. In case of upper cylindrical part, radius is 8 cm and height is 60 cm. So in case of larger cylinder, height is 220 cm and radius is 24 by 2, which will give 12 cm. In case of smaller cylinder, height is 60 centimeter and radius is 8 centimeter. We have to find the volume of this pool, which is volume of the bigger cylinder plus volume of the smaller cylinder. Now we know the volume of cylinder is pi r square h. So for the bigger cylinder it will be pi capital R square capital H, plus in case of smaller cylinder it will be pi small r square small h. From this two I can take pi common. If you take pi common, we are left with r square h plus small r square into small h. Pi as given in the question 3.14. Capital R is 12, so r square is 12 square into h is 220 plus r square, small r is 8, so 8 square into 60. So 3.14, 12 square is 144 into 220 plus 8 square is 64 plus 60. So 3.14, if I multiply these two, it will give 31680 plus 64 into 60 will give 3840. So 3.14 into, after adding these two, I am going to get 35520, and if I multiply these two, we will get 111532.8 centimeter cube. Now in the next part of the question it is given mass of 1 centimeter cube of iron is 8 gram. So mass of this much we have to calculate. So mass of 111532.8 centimeter cube iron will be 8 into this value. So 8 into 111532.8. If I multiply it will give 892262.4 gram. Now if you want to convert from gram to kilogram, we have to divide by 1000. If we divide by 1000, this decimal will shift 3 places in the left side, so it will become 892.2624. If we round off, it will become 892.26 kg. So 892.26 kg is the mass of the bowl. A solid consisting of a right circular cone of height 120 cm and radius 60 cm standing on a hemisphere of radius 60 cm is placed upright in a right circular cylinder full of water such that it touches the bottom. Find the volume of water left in the cylinder if the radius of the cylinder is 60 cm and its height is 180 cm. As given in the question, in case of bigger cylinder, radius is 60 cm and height is 180 cm. In case of solid, in the conical part, height is 120 cm and radius is also 60. So we can write in case of solid, in conical part, height is 120 and radius is 60 cm. In case of hemispherical part, radius is 60 cm. In case of bigger cylinder, height is 180 cm and radius is 60. Now volume of the cylinder minus volume of the solid will be the volume of the water left. So we can write volume of water left is volume of the bigger cylinder minus volume of the solid. Now volume of cylinder is pi r square h minus volume of solid means volume of cone plus volume of hemisphere. Now volume of cylinder already we have written pi r square h minus, for cone it is 1 by 3 pi r square h plus minus minus volume of hemisphere is 2 by 3 pi r cube. From these three I can take pi r square common, then we are left with h minus 1/3 of h minus 2/3 of r. Now pi is 22 by 7 into 60 into 60, h is 180 minus 1/3 of h, that is 1/3 of 120 minus 2/3 of r, that is 2/3 of 60. So 22, 60 into 60, 3600 by 7, 180 minus 120 divided by 3 will be 40, 60 divided by 3 will be 20, 20 into 2 40. So we are left with 22 into 3600 by 7, then 180 minus 40 minus 40. So it will be 22 into 3600, 180 minus 80 will give 100 by 7. If I multiply these 3 it will give 7920, then 000 divided by 7. After dividing it will be 1131428.571 centimeter cube. If you want to convert from centimeter cube to meter cube, we have to divide by 1 followed by 6 zeros, because 100 centimeter equal to 1 meter. Since it is centimeter cube to meter cube, so it will be 1 followed by 6 zeros. So 1, 2, 3, 4, 5, 6. This decimal also will shift 6 places, 1, 2, 3, 4, 5, 6. So it will be 1.131 meter cube. Therefore, volume of water left in the cylinder is 1.131 meter cube approximately. Question number 8. A spherical glass vessel has a cylindrical neck 8 cm long, 2 centimeter in diameter, the diameter of the spherical part is 8.5 centimeter. By measuring the amount of water it holds, a child finds its volume to be 345 centimeter cube. Check whether she is correct. Taking the above as the inside measurements and pi, you have to consider 3.14. As given in the question, a spherical glass vessel has a cylindrical neck of height 8 centimeter and 2 centimeter in diameter. In case of spherical part, diameter is 8.5 centimeter. Now in case of cylindrical part, we can write radius is 2 by 2, which will give 1 centimeter, and height is 8 centimeter. In case of spherical part, diameter is 8.5 centimeter, so radius is 8.5 by 2, which will give 85 by 20, that means 17 by 4 centimeter. Now we have to find the volume of this figure. Volume of this figure means volume of cylindrical part plus volume of the spherical part. For cylinder it is pi r square each, and for sphere it is 4 by 3 pi r cube. From this two I can take pi common. We are left with r square into h. Here r is 1, so I have written 1 square into 8 plus 4 by 3 r cube. R is 17 by 4 we got, so since it is cube I have written 3 times. So this 4 and this 4 can be cancelled. Pi given as 3.14. 8 into 1 is 8 plus 17 into 17 into 17 will give 4913. 4 4 is 16, 16 3 is 48. So 3.14. Here if I take the LCM, it is 8 by 1. 1 and 48, LCM will be 48. 48 into 8, 384 plus 4913. So 3.14 can be written as 314 by 100 into, after adding this 2, it will be 5297 by 48. If I cancel this 2 by 2, it will be 24, it will be 157. 157 into 5297 will give 831629. 100 into 24 will give 2400. After dividing, it will be 346.512 centimeter cube. In the question it is given that the child finds the volume to be 345, but here we got 346.512. As child found volume to be 345 centimeter cube, so her measurement is wrong. It should have been 346.512 centimeter cube. And that's the answer. And this is the last sum from this chapter. I hope these sums are clear. And in the next video, I am going to start sums of chapter 2. Till then, bye bye, take care, and wait for the next part.